Hi folks, starting up the lecture in a minute. Let's see who's online. Not had much of a peep out of people from the chat. It is Monday, isn't it? Well, there's a few people on YouTube. Hello YouTubers. Hello, the one generous Twitcher, thank you for joining me. I'm going to start it up, hey? Let's do this. Just small. Good morning, folks. Thank you so much for joining me live, those who are here live. Thank you so much for watching later, for those who are joining me later. Here I am for another week of COMP1720/6720, streaming live, as always, to you from the studio here in Canberra. Today's topic is objects and interactive art, and not so many people online. There's a few people adding now. I'm really pleased to see it because the interactive art bit is a really serious topic for this week. So far we've done a lot of coding of art. We've done a lot of little programming constructs. But we haven't talked a lot about how to make art interactive. And if you remember the title of this course, it's Art and Interaction Computing. So the interaction bit is extremely important. It's 1/3 of the words in the title, Art, Interaction, Computing. And it's probably the one which is the highest challenge, right? I think most people found in assignment 1 that there was the possibility of making something creative with a computer, making an artwork. Super great. And by the way, assignment 1, really pleased to see so many really cool monsters. And I'm seeing them now pop up on the discourse in the pre-lab. Is an example of someone's cool monster. Another cool monster. That was a cool monster. Just a pet rock. Cool monster. folks in the pre-lab. The pre-lab this week was to talk about your monster from assignment 1. So pleased to see those cool pre-labs showing up. Let's start it up. Oh, there's one person on stream. Welcome, stream viewer. Does anyone talk to me? This is the lecture chat for the day. Yes. Yep. Anisha. Just going back to this way. Last week I tried something weird with Teams. Tried something a weird, different stream on Teams. Didn't like it. I like this way. I mean, I'm not sure if I like it or not. We can try different things over time. Let's start the content. First of all, admin corner. Assignment 1, marking is underway. I'm really impressed with all of the monsters I've seen. I've got a way of looking at them all at the same time. And there are just some wonderful, wonderful ideas that people have had. And I'm just so pleased to see people engaging creatively with computing in this course, because that is the fundamental thing I want to talk to you about in this course, is building this grounding in how to use computing as a creative activity, creative output for you, and building some kind of experience and practice about how to make interactive creative artworks with computers. So the assignment 1 marking going along. Assignment 2 is actually out. Assignment 2, I announced it on the forum last week. Not a lot of folks, I think, have seen this yet, but assignment 2, there is a link here, A2 workstation. I've also got a kind of placeholder for assignment 3. Haven't filled that one out completely yet. It's not going to be released until, not released properly with a template for you to start, until after assignment 2. Assignment 2 is called Workstation, and your goal is to create an interactive workstation in P5. So it's different than assignment 1. How's it different? First of all, you're not really making a character in this one. You're making a kind of scene or something where there's lots of different things. And in assignment 1, it was strictly not interactive. You could create a dynamic artwork where there would be movement, but you couldn't have interaction with the mouse or keyboard or any other way of doing it. So in this, the goal here is to make some kind of workstation. Like you look down at your desk, what do you see? A keyboard. I see a mouse, I see a keyboard, I see a Wacom tablet, I see a water bottle, I see some headphones coming from my audio interface. Whoop. I see a synthesizer, I see a microphone, I see an iPad, I see my phone, like all this stuff that I use to do my lecturing, and maybe I could make an artwork where I'm moving around my desk and operating them all in a different way. So you can create the kind of workstation that you want to do. I've got a few examples here. Your messy desktop, spaceship control panel, a baby activity center. I think that could be a really fun one. Like this, I don't know. I mean, I've got a toddler, and so I spend a lot of time thinking about different kinds of toys that my toddler would like. Obviously older than this kid, but it's more like this. Plays with different stuff in that way. And an air traffic control, a very serious kind of workstation. I got a cool picture of an air traffic control here, including, I think this must be a very old picture. That's a Apple Newton, it looks like. Weird. Anyway, so lots of different ways of contextualizing a workstation. A painter's studio, a maker space, like in the image up here. There's a maker space with some soldering station, a laser cutter, a computer, bits of tape and things to make stuff physically. A checkout on a cash register, a self-checkout center is a kind of workstation. Lots of different ways that you can imagine a workstation. And the common thing is that it's a variety of objects that a human would interact with to accomplish a task. That's a workstation. You don't need to overthink this too much, but if you're creating something that has a variety of objects that you interact with to accomplish a task, that can count as a workstation. And now what the goal of the assignment is that you have to make a workstation which is a piece of art as well. So it can't just be splat on the desk some things and they, react in one simple way. They have to work together to engage a user, and we'll talk a bit about engagement today. The workstation should be engaging, coherent, and rewarding to interact with. We'll talk a bit more about reward today and interaction, because we haven't talked about that at all in this course yet. But the rest of the requirements are very simple. You should be used to these now that you've seen assignment 1. Has to be a workstation, has to be interactive, has to be engaging and coherent, has to be rewarding, that's important. The size, you don't get a choice, has to be 1280 by 800. You're again going to include a thumbnail image. Again, you have your code in sketch.js, unless you've got a particular reason not to do that. Again, you have to have an artist statement. Again, you have to statement of originality with at least 2 sources. Must nots. Again, this is about drawing. This is not about loading images from the internet or creating pictures in some other way and using them for your workstation. I want you to focus on P5's drawing. I got some feedback from someone which was that they like to use image and asked if I could just ban load image. Fair enough. If you've got a reason to use image, which sometimes you can use that to save the content of a P5 sketch. Load image is about loading an image from a file. So don't use load image, but you can use image if you really want to. Must not use sound. We haven't talked about sound yet. We will start talking about sound next week. But this assignment, no sound, please. Finally, or a few more things, one more thing. For interaction, I'm really looking for keyboard and mouse interactions in this one. There's lots of other interactive methods you can use with P5, more advanced, complicated kinds of interactions with the camera, microphone, or other sensors. I don't want you to do that yet. So just hold your horses. Hold your horses. I know that you really want to start loading images from that camera, but leave that maybe for your major project or the late assignment 3 when we've had a chance to look at some of these things in detail. Last one, and this one can sometimes be a little bit of an issue in this course. You must not make a game. You must make an interactive artwork. And this goes for all of the assignments in this course. We're not a game development course. If you want to take a game development course, you can do game development. We're running a course on it next year. Games are different than interactive artworks. I'll talk more about that in this lecture. But just as a rule of thumb, if you have an artwork which involves a score or a concept of winning or losing, you may actually be making a game, and that's not what I want you to do. So think about I'm going to talk to you in this lecture about interactive art as a concept and about how that is different from a game. I don't want to go into this too many times, but folks come back to me and they just come up with games and they say they're interactive artworks, and I think, no, they're not. Same idea for the artist statement as before. Same repo as before, same idea, same concept for an assignment repo. Fork it, add your code, CI checks. I think we've fixed the issue with the size of the thumbnail image this time, so that should help people not complain. Basically, that if you have any more questions about this assignment, we have a thread on the forum about it, and I would encourage everyone to keep track of what's going on the forum. No replies yet, and only 1 heart. So please heart my thread and reply to it. Due date, 5th of September 2022. That is the first Monday of the mid-semester break. So from today, you have 2 weeks. So this was released last week. Most people will do this at the last minute. Okay, that's fine. That's how people organize their time. It's your business. I would suggest that you get a head start on this early so that you can see some of the issues coming for you, have a chance to have a few goes at this and think in between, because artistic practices do take practice, not just doing it. Okay. Last thing, course survey. There's actually 3 kinds of surveys available in this course. You might have seen this if you've visited Wattle recently. All our surveys run on Wattle. There's just a reason that happens, but we've got a survey in week 4 and 5. I think there's a survey in week 8 and 9. And there's also a survey you can do at any time. If you just have something you want to tell me about how you're going in the course, you can do the anytime weekly pulse check survey. But the week 4-5 survey is actually open. It was open last week, week 4, and it is open until this Friday, 5 p.m. So I see that submitted answers is 13. I'd really like to get that number higher. I'd really like to get that somewhere close to 50 or 60. So I get about 50% of students in the course answering the survey. That would be really, really, really cool. The reason I want that is because the survey is one of the only ways I can know what you're thinking in this course. I don't know if it's too hard for you, if it's too easy, if there's anything we could possibly do about tuning the second half of the course to meet people's needs better. And we do. When people jump in, people jump into the course coming from different places, they give me some feedback, and if I get feedback now, I might be able to adjust something in the second half of the course within what I'm able to adjust, because some things are just set up at the start to make that work better for folks. So please do the survey. Just go onto Waddle, do it right now. I'll wait, and I won't wait, but it only takes a minute to do it. There's a few questions where you like strongly agree or strongly disagree or whatever, and then a couple of questions that say, what do you like about the course? What have you found difficult? And what would you change? I think those 3 questions. And this is a great time to have those in. We'll talk about the survey responses next week. But someone said, I want to use image, and I thought, well, that's okay as long as you don't use load image. So I was already able to adjust the assignment to accommodate that person. Thank you, that person, for filling in the survey and telling me something that I can do. Someone's asked on the team, can it only be mouse interaction or keyboard too? Both keyboard and mouse. Okay. What did I say? I said just the keyboard and mouse. Must not use camera, microphone, or other sensors. Just the keyboard and mouse. That seems pretty clear. Okay. Close that survey window. Close this. That's admin corner out of the way. Let's talk about code. Last time we talked about arrays, and that was a way of bundling up multiple things and then getting each thing back from our little bundle. I'm actually recording, hopefully, yes. Getting each thing back from our bundle with an index, so they were in a bundle in an order, which was really useful. That let us make our Firefly sketch, where we had a big array of all of the X values of the fireflies, a big array of all the Y values, and a big array of all the brightnesses. So that lets us keep track of multiple things. And when we combine arrays with loops, we did a cool thing where we had one number that could control the number of fireflies. So the number of fireflies 100. We can just change that one number. I only want 10 fireflies now. Okay, 10. I want 1,000 fireflies. I can make 1,000. So how powerful is that? You can suddenly have one variable which changes all of the other values in your sketch, automatically creating more of things and storing them in those arrays. We also discussed functions, which was a way of bundling up some code, again a bundling method, bundling up some code and running it multiple times using arguments, the parameters of a function, to change the outcome predictably. And now we get into this final, I think it's really the final code idea for the course, because from now on we talk more about interaction and special different kinds of media, including sound. We're going to talk about objects today, and objects kind of combine these two ideas, because an object can bundle up multiple pieces of data, and it can also include functions that do things. We're basically only going to talk about the first bit of objects today, the bundling up of data, in a different way than an array. But we will cover the bundling up of functions as well at a later date. Not the kind of thing we can do in 1 week, particularly if someone is a genuine first-time coder in this course. And I know those folks are here, and I know those folks can sometimes panic a little bit at this stage of the course. The good news for them is that we spend the rest of the course practicing the things which we've been introducing over the last few weeks. What's an object? Here's an object. It's a watch. Name a thing that it exists. It's a watch, so we can give it a name. How would we describe it to someone who's never seen it before? Well, I suppose we could think of the aspects of a watch. The color of the watch, in this case black. The kind of display method, analog watch or digital watch. The brand, this one's a Casio. Oops. Lost my little pointy point. The functions, it's got an alarm and it's got a stopwatch in it, and that's it. It's very simple. Oh, it's got date as well, date display. So we could start to create a kind of description language for the watch. Color, black. Mode or type, digital. And you might imagine that most material, rubber, or resin, I think they call this, resin case. You can imagine all different kinds of watches would have different varieties of answers for all these questions. Brand, functions, might be an array of things. All the different watches would have different answers for that. And so if we had all the watches in the world, we could specify different ones by having different answers or different data in each of these little categories. So, as we saw from that example, often you need multiple attributes to fully describe a thing. So to fully describe a student, we could have their name, their age, the course they're taking at uni or their program. You could fully describe an address, which would be the street name, the number, maybe a unit number, the suburb, the town, the country. You could have a pet, a name, species, breed, owner. The higher level idea here is that we're taking multiple bits of data that are related and putting them together to describe one thing. And so that's what this programming idea of an object is. Take multiple bits of data about one thing and keep them together in one place. So rather than having var color, or sorry, let color, let brand, let mode, etc. for the watch, we can just have one variable that contains all of those bits of data. So let's just think about definitions of this word object. Where does the word object come from? Well, in regular standard English, an object is something mental or physical towards which thought, a feeling, or action is directed. Well, that's a pretty good description of just a thing. In programming, an object usually means a data structure that can contain functions as well as data, variables, and other data structures. So that's a bit abstract, isn't it? But there's an idea that an object, the watch object, for instance, could contain all of the data, and then also some functions. And that is the case in JavaScript as well. But today we're not going to talk about the function bit, we're mainly going to talk about the data bit. Because the data bit is really immediately useful, and it's immediately useful. I'll show you when we go into the Firefly sketch from last week to make that work better. So, let's make a Pokemon. What properties does a Pokemon have? A species, a level. Everyone's played Pokemon, right? It's got to be like 100% standard knowledge. But this is called a Pokemon. It's a kind of animal, and they each have different characteristics about them. And people capture these Pokemons and put them into battles until one or the other of them faints. Which seems a bit cruel, doesn't it, when we think about it? And this is a game given to children. A game we give to children about fighting animals. What is going on? Oh, anyway, it's all very fun apparently. Well, I had a lot of fun with it when I was a kid, and kids still do. Pokemons have a number of hit points, which is the number of times they can get attacked before, or roughly records their strength of resisting attacks until they faint. And they have an owner, because someone has to own these Pokemons. Pokemons just can't be free agents wandering around the world. Well, they can, but eventually they're captured by an owner in a apparently so-called mutually beneficial arrangement, which doesn't really make sense to me. Favorite Pokemon? Don't know if I can remember. I'm only really able to recall Gen 1 Pokemons. The original 151. I'll have to think what my favorite Pokemon is. I reckon I was always in terms of starter Pokemon, I'm going to say favorite starter, I was always a Squirtle fan. I did have Pokemon Blue, and I was more a fan of choosing Squirtle as the starter rather than Charizard or Bulbasaur. So, and of the Squirtles, I think I never really liked Blastoise. I liked Wartortle. So maybe Wartortle's my favorite Pokemon. Anyway, it's beside the point. So Pokemons have a number of these different characteristics, whether they're captured or not, and we can put these into a JavaScript object. So here's our first object. Let Sally the Pokemon be a Pikachu species, level 1, HP is 100, the owner is Ash Ketchum, the ubiquitous Pokemon player, and captured is true. So what can we see here? We're defining a variable, just as we normally do, let Sally, and then we're defining it to be an object. So remember that when we use the square brackets, that meant array. The curly brackets here mean object. And you might say, but Charles, we've already used curly brackets to bundle together lines of code in a function. And I would say that's very observant of you. Unfortunately, in programming, sometimes we use the same symbols to mean multiple things. And that is confusing, yes. Reality, yes. It is just the way programming goes. Unfortunately, we only have we've got 4 kinds of brackets on a regular keyboard. Regular round ones, square ones, curly ones, and angle ones. So the options are limited. We don't use the angle ones all that much. We could, but they're often in a weird place. Well, it depends on the country your keyboard is set to, really, where the keyboards are. Anyone who has a European keyboard, I pity your programming speed, because the brackets are not in convenient places. Okay, species Pikachu, level 1. Let's also think about this. As with arrays, with objects you're allowed to have different kinds of variables inside it, different kinds of data. So there's a string, number, whoops. Just got to turn this around so I'm actually writing in a sensible way. Number, another string, and a boolean. Unlike an array, each of the bits of data has a name. And the name, in this case, is a string. And we don't need to put it in quotation marks, like we have to put Pikachu and Ash in quotation marks. We don't have to put this string in quotation marks, which is handy. It makes it faster to code, doesn't it? And between each name of each sort of sub variable within the object, we have the colon symbol. So it looks pretty straightforward when you read it. It kind of makes sense, right? We've got a variable called Sally, and here are the properties of Sally. Species, Pikachu. Level 1, HP 100. Owner, Ash. Captured, true. And then we close it off with the closing bracket and plonk a semicolon after it, just for good measure. All of the bits of data inside an object are called a property. So the components of an object are called properties, and each one has a name and a value. So the name goes on the left side of the colon, and the value goes on the right-hand side. Now, we have to be a little bit careful about language sometimes. And this is particularly, may not be clear to someone who's new to programming, but it can happen at any time that we have everyday English language or any language where there are often a bunch of words which are kind of interchangeable. And some could be these ones: property, attribute, characteristic, trait, aspect. They all kind of mean a thing about a thing, a description of something, an aspect of something, a trait of something, a characteristic of something. They're related concepts. But in programming, these things can mean different things. And I mean, it's just you raise your hands in frustration when you see these things happen. But that's just how programming is. We often just have to be precise about our language to mean what we mean. So be careful and remember that objects have properties. They don't have attributes, they don't have characteristics, they don't have traits, they don't have aspects, they have properties. So, sorry, people are chatting to me on Teams. Any more? You can't access JavaScript variable names. Don't know what you mean. I mean, Melody's just commented about something and used the word attribute, which has confused me. Are we talking about properties here? I don't understand the question. I mean, this gets to the point in JavaScript where there's a lot of different ways of doing things, and I sometimes don't understand the question on purpose because we need to have a more detailed discussion about it. Object syntax. We use the squiggly braces. We've talked about this. The spaces don't actually matter, and the line breaks. These are all the same object. No spaces, spaces in between the braces, squiggly brackets, and the variable, the value and value, the property name and value. Having line breaks doesn't matter, it's all the same. If you have multiple properties, you have to have a comma in between them. So what can we do with objects? What can we do? Just like arrays, there are a few main things you will want to do. You will probably want to get values out of it, often called accessing a property. You'll often want to set or update the values of properties. We're going to do these today in our demos. You might want to add a new property and a new value. Could happen sometimes, not always needed, but you might need to do that. All of these things are possible, and more actually, but these are the main ones. Two main ways to get the value of a property. This way, Sally.species, I love this way. I love dot notation. And then a slightly more wordy version or characterful version, Sally square brackets, quotation marks, species. Both of these things will get you back the value of the species property. The dot version and the square bracket version, they return the same thing. When to use the dot syntax. I love the dot syntax. The dot syntax is a little bit easier to type. It looks neat. Looks cool. Looks like you've made something cool and the computer now gets to use it. Having things in brackets, in square brackets with the quote marks around it, looks a little bit annoying. It's going to be longer, have a few extra characters. I just don't like doing that. But there's some situations where you do have to do that. And the specific situation is that if your property name isn't a string, if it's actually a number, like this one, let ben object equal object braces 5 : howdy, that property name's a number, not a string. So this one is not going to work. Ben object.5, no, not going to happen. You would need to use ben object in square brackets 5, the number, not the string. If this looks like an array, now array indexing, to you, then you are very observant and correct, because arrays are actually objects where all of the properties have a number and the number is their index. Let that one sink in JavaScript. If you're used to other programming languages, you might not get that link, but that's truth. Back to this question. That would make it hard to like print an arbitrary Pokemon name without having it as a property. Oh, no, yeah. Yeah, so I think you're taking the example a bit too far, Melody, yeah. But it's just an example, because normally you would have the name as the property. And the variable name would just be like P for Pokemon. Setting the value of a property. What if we need to change a property or update it? So just like arrays, you can change or assign a new value to a property with the equals symbol, the equals operator. And these two lines are exactly the same. Sally.species equals Raichu. So Sally has evolved from Pikachu to Raichu. Sally.species equals Raichu. Same thing, different notation. Updating the property of an array. This is a good one. You need to just change it a little bit. You can do a get and a set in one line. Sally.hp equals Sally.hp minus 10. We will do this in the demo. Very useful technique. Sally.hp minus equals 10. A little bit quicker to type. This is a good way of, a neat way of saving some characters and making your code shorter and cleaner. The one line update operator. Sally minus equals 10. We can also do plus equals. Adding new properties to an object. In some programming languages, they might not like you doing this, but in JavaScript, it doesn't care. If you've got a object that has no property called hat, you can just set it, sally.hat equals true, and now it does. It doesn't complain, doesn't care. You can add these properties, and now Sally has a hat, which doesn't seem that useful, but it may be useful the same just to add properties to things. Sometimes I read some JavaScript and I do get confused about why you're allowed to do certain things, and I've forgotten that you can always just add properties, any rando property you want to an object, and it's fine. Weird stuff, but true. Can't remember the context of trying to figure out how that happens. Oh yeah, for a system called Jibba, a live coding system, live coding music system written in JavaScript. So once you've declared your new property, sally.hat equals true, that's now been added to the Sally object. If sally.hat, I guess you draw a hat. This may be useful, it may not be, but it's nice to know that it's there. Now, you may think so far, well, I've done a whole assignment and drawn a whole monster with no objects. Why me worry? Why should I worry about these object things? But in reality, I might need to sneeze. Sorry, whoops. I cannot get away from one kind of loud, uncontrollable mouth thing or another. It's either coughing or sneezing. One of the two. Where was I? I was here. You may think you don't need objects because you've been making a whole assignment and all of your labs with no objects so far, but that's because these things, we've been able to do these things without worrying about objects at this point. But objects are super duper useful, and they're particularly useful because you actually use objects all the time in P5 without knowing about it. Whoops. For instance, you can make a color, store a color just as a variable, in which case, oh, it's nice in the little editor, it gives you a little color next to it. In which case, there's the color, let magenta equal color 220.0220. This function color takes some numbers and returns an object with the data of that color in it. So let's print magenta into the console and just see what it looks like. If you want to see an object, the best thing to do is print it. There it is. You've got your whole, there it is in object notation with the curly brackets around it, and you can click this little thing to unload it and see what all of the properties and functions of it are. So the maxes is actually another object, the max values. The array is an array version. The levels are an array with the data in there. It's got a bunch of functions here, toString, set red, set green, they're all functions. We'll deal with the functions inside objects another day. A bunch of other functions that are probably not useful. Underscore things in objects, it's a sort of a programming technique to sometimes officially or sometimes unofficially say that this is not meant for users to use, like they're kind of internal parameters or internal functions. So you normally wouldn't use one of these underscore functions. So the main part where the data is stored is here, an array inside the object. Oh, someone's got a question. I'm really excited about it. I'm just going to go back to the Ben object slide. I'm going to make the object here in P5 and we can have a look at it. So, the confusion. Does Ben object 5 refer to the property name or the index? Suppose Ben object equals this, and they've typed in something. X equals something. Y equals hello. 5 equals number. We'll keep it howdy. Z is hi. And G, I don't know why we need so many, is hat. Ah, I see. I think I understand the question now. Oops. Let's print Ben objects. So the question was, does the number, Ben object in brackets 5, give you the 5th property, or does it give you the one with the label 5? It gives you the one with the label 5, but in an array they're the same thing. There's some way to change an array into an object, but I might think about that another day. You can see that these things all have their labels, and it's changed the order when they go in. The order of these things doesn't matter. The order of the value of the properties of an array are defined by the numbers that are given to those, the names of the properties. So Ben object 5 is going to give us howdy and not the 5th one. 0, 1, 2, 3, 4, 5, or the one after that. Howdy. So it refers to the name. How to call a property based on an index. That's how you do it. So if I did have an array, Ben array, uh-oh. I'll just print the array. Someone tell me how to make something and turn it into an object. Uh-oh, Ben with 2 R's. If someone can remember how to cast it as an object, I'd be happy. But the point here is that arrays are implemented as objects in JavaScript. So they actually use under the hood inside JavaScript, it uses the same ways of referring to things. So an array is an object that happens to have only specifically properties with numeric values in order from 0 to the length of the array. So if you want to call a property based on an index, well, objects don't have indexes. Only arrays have indexes. Only the special kind of objects that are called arrays have indexes, because we know that those kind of objects will have numeric names for their properties, and those numeric names will start at 0 and increase up to the length of the array. So the word index only makes sense for objects that happen to be arrays. You don't really have to worry about whether arrays and objects are the same. It's just a bit wild to imagine that they are the same in JavaScript. I wonder if you can just add an extra property to it. Ben array.hat equals true. Is that going to work? Yep. So if I now print Ben array, no, it hasn't done it. It's only printing it as if it's a function, as if it's an array. But that array does actually have an extra property called hat. Oops. We'll stop that and keep moving. Where was I up to? Making things under the bonnet. Oh yeah, okay. Last bit, almost the last bit, we can nest objects together. So if you have an object called car, you can have a sub-object here called paint. So now if I wanted to get the color of the paint of the car, I can say car.paint.color. Dot notation, love it. I love having these strings of dotted things getting inside an object. Someone has helpfully found the way to turn an array into an object. Object assign. I mean, this is some deep JavaScript here. I don't really expect people to know it. Is that going to do it? I'll just print that, whatever that returns. Okay, now I've got the object version of the same thing. There's the array, 0, 1, 2, 3, 0, and now we've got the same thing except with a object notation, 0, 1, 2, 3, and then hat, the property. You can have arrays and objects together. Arrays are still really useful, by the way, and we will keep using them. If you had a whole bunch of ants, or species of ant, you could have them in an array, and each species of ant could have multiple properties. So each ant could have a species and a size. Fire ants are only size 100, whereas giant ants are size 500. That's great, we've got two different kinds of ants there. You could have an object with arrays. So you'd have a hand of cards in poker. Your hand could be divided by the cards that you happen to have in each suit, hearts, diamonds, clubs, and spades. You might have no spades, you've got the 5 and 6 of clubs, the 8, queen, and king of diamonds, and the 2, 5, 7 of hearts. I have to think about it to work out if this is a good hand or not, but it's a hand. It's a description of a number of cards divided by their suit. And then if you wanted to work out what clubs you've got, you could get pokerhand.clubs, and then you can index into the array. So the clubs have index 0 is 5, and index 1 is 6. So this little line of code here is going to return 6. So a lot of this stuff is very familiar. I did say that, I've said this before, arrays are objects. It just happens to be that in arrays, the property names are the numbers 0, 1, up to n-1, where n is the length of the array. Not something we need to worry about on a day-to-day basis, but it's just good to know that these things are related in JavaScript. Which should I use? Rule of thumb, use objects when you've got several related values with different types and that you want to have names for them. So the make, the model, the color, and the mode of a watch are all separate types of data, and they have a name attached. When you've got a bunch of things that are the same and they don't need specific names, use an array. So you might have 10,000 watches in a box, and it's good to refer to each one in an array because it doesn't really matter you don't want to give names to each of those 10,000 watches. You just want to have them numbered and accessible in a big list. And you can definitely have arrays of objects and objects of arrays. No worries. So, this is the Jungle JavaScript page. There are a lot of details about objects in JavaScript. You can definitely look up on the JavaScript MDN page for objects. If you look here too deeply, you might have a curve of confusion where you get maximally confused after some point and then hopefully understand it more in future. I feel like I'm still on the downward slide of the curve of confusion with JavaScript objects. I'm not a JavaScript programmer in general. JavaScript is something that sort of happens to me occasionally in P5, and I still don't really understand what's going on with objects sometimes, particularly when you want to make new objects that have functions and have preset properties under some conditions. We'll look at the ways to make objects that have functions a little bit later or in the course. For now, I just wanted to get this way of putting data together because it's so useful to do that. Most important thing here is to understand the concepts and to practice. Oh, this is adding the functions. One way of doing this. This one seems legit. We make a point, x and y, and here's adding a function to it. Red background, there's the name, and the actual value of it is a function with some code in there. Totally legit in JavaScript to do this. So this is adding a function to a object. Oh, I forgot I had these slides right here. Oh well. The function is a value just like a number. So the value of the property can be a function. So that is one way we can add functions to objects very easily. Methods. Methods are a special function that live inside an object, just like properties. So objects have properties and methods. Properties are the data, methods are the functions. And here's an example. I'm not going to go through this now. We will look through this on another day. Does it actually have a method in it? No, it doesn't. It's using a method. Yeah, not a good example. That's why I didn't want to do it. All right, second part of the lecture. And this is the part which really specifically relates to the assignment. This is our entry point into interactive art in this course. So what is interactive art? What is art? We've already discussed that one at length last 4 weeks. What is interaction? Well, that's interesting. I guess you would imagine interaction is some kind of actions that you take, and then there's another thing which is reacting to your actions, and then it takes actions and then you react to them. So it's a kind of feedback conversation between two things, A and B. A does something, B reacts, B does something and A reacts, and then there's a feedback loop. So this is interaction. Two things acting and reacting to each other. And how can we design interactions in P5? And here the interactions are really between a person who's viewing a P5 sketch, probably on a computer of some sort, right? The computer has keys and a little trackpad. Maybe it has a camera, it might have a microphone. So they can see something on the screen. Normally people react to the art that they see, and then they take some action through the sensors and modalities of the system that they have in front of them, the computer, and then the computer does something. But we need to design the kind of things that it does to make them artistic. So this is important because it's art and interaction computing in this course, not just art computing with a side of interaction. So what makes art interactive? If you Google interactive art, it turns out that it's a whole thing. It's a name of a genre of art, just like painting, sculpture, glass, textiles. I'm trying to think of other art forms. Photography, interactive art. It's not the same as all kinds of things, but it's not all kinds of art that looks like interactive art is the same, but it's art which deeply involves the people who are viewing the art as participants in the art. To make it complete, you need to have people there doing the thing. And here's an example of this of the start of this movement. We're moving later than we were in the previous lectures. We talked a lot about the very early 20th century for contemporary art, modern art. And now we're looking in the 60s. A Day in the Street, an interactive art event. And this was here is the art. It's these little blocks on the ground. But the blocks by themselves, you can't just take a picture of the blocks and say that's the artwork. The artwork is people standing on the blocks and doing something with them. And the blocks have little tilts so they move as you walk over them. It's a sort of an activity. So the art is presenting a way for someone to interact with it. The viewers of the art decide they're going to interact and they do the thing. And then the experience kind of gets better over time because now you see that there's people on the things, not just blocks on the ground. Another concept, another thing from the 60s, this is actually a reproduction of a collection of interactive art objects by this group called GRAV, Groupe de Recherche d'Art Visuel. Again in the 60s, and if you're interested in OHS violations, this one has some pretty crazy ones. I love this. Very high, crazy stairs where you could very much fall off. And of course, the people who are most interested in this kind of art, this kind of interaction, are kids who just love to climb on cool things that look like they're dangerous and push their limits. So many, I guess these are interesting, weird stairs that you could go up and down. And there's interesting, springy chairs that you could sit on and move around. And there's this thing which I guess wobbles from side to side in an interesting way. And there's this thing which I guess you kind of go inside and then you see the world filtered around. So again, it's things that don't make sense until a person is there interacting with it. And the experience of this art, you can't just see the picture and quite get it. You have to be there, be in the room, climb on it or touch it or be part of that interactive experience to see what it means. But this is 60s interactive art. So this is where what I'm talking about comes from. We're really talking more about ways of interacting with a computer. And to go somewhere in between, here's another work from the 60s by Namjoon Paik, famous work called Magnet TV. And so there's an old TV, relevant to the era, a black and white TV, and this huge magnet. And I suppose you folks have probably never seen a TV like this, but they have a big screen. They're deep because they have a cathode ray tube that makes the image. And at the back of the cathode ray tube, there's a thing spraying out electrons at the screen. And when the electrons hit the screen, they make a little light up on the front of the screen, on the chemical that's on the inside of the screen at the front. And the way that electron beam is controlled is by big magnets at the back of the screen that guide the electron beam to scan down the screen and make the image. So when you put a big magnet on the screen, it completely messes up the image. And it was a really fun trick with a TV when I was a kid, when these TVs were really common, was to just put a magnet on a TV and see how much it would mess up the image. But this person, Namjoon Paik, turned this into an interactive-ish artwork where the placement of the magnet on the TV would create an image, and obviously that's something which people could change. You could pick up the magnet, move it somewhere else, put it on the screen, and change what image you would see. So although this image is cool, the experience of this artwork isn't just seeing one image, it's in moving the magnet and seeing how different images come out. Moving on into maybe the more contemporary era, the computer era. I've got a few contemporary or more late interactive artworks getting up to now, where we look at P5 interactive artworks. This was an artwork in Canberra. It actually still exists, called Illumicube, and the original version was sitting in Ainsley Avenue in Civic It's moved to a different location, but where it originally was, it would have lights inside it. I don't know if it still works. So someone said that thing lights up because they've seen it. It did or does. I'm not sure what the status of the IllumiCube is right now, but the original one lit up and it was sound activated. So you would see it as a cool sculpture, these glass bricks in a cube, pretty striking, and then it would, as someone would walk up to it, the sound of their footsteps or the sound of a car going past would trigger the lights to turn on. Great artwork, and it's evolved over many years. So now 1988, it's now more than 30 years old, and the sculpture itself has moved into a different spot. What am I linking to? Someone's blog, I think. IllumiCube at night. Oh, that original one from Archives ACT. It's moved into a different spot and it's had its lights replaced. The reasons the light had to be replaced was that since 1988, Canberra has become a much busier city. And what would happen is that people started to live in Civic. So at this era, no one lived there. Civic was just shops and office buildings. Now there's apartments around in Civic, and a lot of people live in Civic. And in the middle of the night, people would come and shout at the IllumiCube to make it turn on. And that turned out to really irritate people, so they changed it to being movement activated or just having a show. So it had to lose the part of the cool interaction, but a really cool interactive artwork because it was a sculpture, but it sort of was reacting to the world around it, and the actions of viewers who would come up and work out how it worked and play with it and experiment made for a richer, more engaging experience, enhanced experience. Iamascope, something from the 90s by some art and music folks, Sid Fells and Kenji Mase, was a kind of kaleidoscope made with computer vision and computer graphics. And the computer vision bit would be tracking where someone was standing in front of it and using that information to update the kaleidoscope image. And again, there's using the person to drive the art making experience. If no one's around looking at it, this artwork doesn't work. It has to have people there to interact with it for it to work. You can read more about it. There's links available. Strike on Stage, another artwork. This one's from the 2000s, 2010. Actually, it's an artwork of mine, or a collaborative work with myself and a friend, Chisha Lai. This was computer video, graphics, vision, and audio, and we created this work as an interactive stage setup for a percussion performance. So Chisha and myself are both percussionists, and we would play on these drums or whatever instruments we'd brought in front of the screen, and the computer vision aspects would sense our movements and use that to update the graphics on the screen. So the artwork by itself would be cool, but it wouldn't really work unless we were there interacting with it. Different kinds of artworks using smartphones. People think about different computers and how they might be able to create unique artworks. So this work called Inkspace was a way of tracking movement of a phone to create a little artwork and share it with people. Zach Lieberman's work from 2015, using the sensors of a phone as the interactive input. And this one's called Mount Rothgo. It's a processing work by an artist called Yu Zhang. And this work again uses some cameras, uses some microphones, and uses this display of a P5, or I think it was processing, a similar language to P5 system to display an interactive, evolving artwork that doesn't work unless people stand in front of it, think about it, interact with it, learn how it works, and try to exploit the experience. So, taking a step back, I've given you a few examples of interactive artworks, what I think of when I think interactive artwork. What is interaction again? Well, in this article called Cybernetics in Society and Art by an Australian artist called Stephen Jones, he had this great figure. I just love this figure because it's obviously made in Microsoft Paint, but really, or something equally silly, but really describes the concept of interaction. You've got two things in interaction, person A and person B. And interaction is a loop between two things. Person B initiates some kind of action. Person A responds, person B responds again, person A responds again, person B responds again, and each time the feedback and the response is different. So it starts out as a straight line, then a dashed line, then dotted lines. So the reactions and feedback are evolving over time. And our goal with an artistic interaction is for the evolution of the interaction over time, the feedback and responses, to get better, to enhance the experience. And that was what a point that was made in the work about Iamascope is that, well, this is a cool thing. You play with it for 2 seconds, you can start to see how it works. But people would stand in front of this artwork for 10 minutes. And after they'd started to learn how it works, the experience would get a lot better and they were able to do specific things and explore it in a specific way that was unique to them. So the experience would be enhanced by the specific pathway of feedback and response that the user or the participant or the viewer would go through with the artwork. So this one over here is the artwork. I'm going to turn them into a screen and a laptop keyboard. So the artwork tends to initiate this, right? Because it just exists in space, that you see an image. A person has to come back and respond to that image on the screen in some way, by standing there in those ones that use a camera, or using a mouse, or using their phone to try to do something. So that begins, the first response begins the interactive cycle. So what's interactive art again? Art that reacts to the participant, art where input from the participant drives the artistic experience, and art where there's a feedback loop between a participant and the artwork that enhances the experience. 3 things. If you don't have these three things, I'm not going to call it interactive art. And you can see how this aligns with my requirements for assignment 2 now, can't you? Because I'm requiring you to make art that reacts to a participant, where it requires interaction to get the artwork, and where the act of interacting enhances what you're doing. It's rewarding. So here's a technical question. How does the participant know what to do? And how do we know that interaction will enhance experience? How do we know it will enhance it? Well, luckily, we have a whole field of computer science called human-computer interaction, which deals with these 2 questions. How do people know what to do? And how do we know that the experience is enhanced by the interaction? Now, this is a course that it goes into art aspects of this. We only touch on a few aspects, but I'm borrowing tools from HCI in order to explain interactive art. And similarly, HCI borrows a lot of tools from interactive art to explain other kinds of computer systems that are interactive. So here's a concept from HCI, or a concept from design, affordances. This is from a book called Don Norman, Design of Everyday Things, and Don Norman really made this concept famous in human-computer interaction. So an affordance is a property of a thing that supports an action possibility. So if you have a door handle, the door handle presents the possibility of opening the door. If there was no handle, you can't open the door. So the door handle is an affordance to support door opening. What are the affordances of a computer? Just by itself, no software involved, just the computer. I suppose you could type on the keyboard. You could use the mouse. You might be in front of the camera or not. You might be heard by the microphone. Anything else? What other things can you do with a computer? Someone jump into the chat. Tell me a thing you can do with a computer, just by itself with no particular software. Is anyone there? Anyone listening? Crimes. Yeah, I suppose crime is an action possibility, but it's not really an affordance of a computer more than an affordance of a human. I guess I could mention something. When computers came out that started to have a camera in the screen, some of my colleagues who were musicians were working out ways to use the screen of a laptop as a kind of accordion, an accordion. So the light sensor in the screen, I think sometimes they have a camera and a light sensor. The light sensor would, as you open the screen, it would get brighter, so they could just sort of go whoo, 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 whoo with the laptop screen and use that to create a sound, a really weird affordance. What about a phone? What are the affordances? Touching the touch screen, clicking the buttons if there are buttons on your phone. I guess phones often don't have buttons anymore. You can take photos of things with a phone. Moving the phone around in space. Taking calls is an affordance. Sending SMS messages. There's a very old example of a mobile phone music work where everyone in the audience had to send messages to a certain number, and then that would drive the performance. So that we're using the affordance of a phone, that it can send an SMS message to enable a group of audience members to perform in a piece of music, creating an interactive artwork that relied on having everyone there participating. What about this? And this one's a bit abstract. It's another artwork by Zach Lieberman. Just as an example of an abstract artwork or an abstract thing, what might its affordances be? Well, we don't think there are any hardware affordances here. We don't think so. We can't see them, obviously, anyway. Suppose there could be software affordances. If this was a system you could use with your mouse, you can move your mouse around. Maybe there would be things that you would discover if you're moving your mouse around. So there could be hidden affordances. As you move your mouse over here, something changes, something occurs, or a new shape appears if you move your mouse over here. So the world could be full of hidden affordances that aren't obvious on first glance, but you have to interact to find them. And that discovery process can be very engaging. So that's something which is often used to lead to high engagement. So I think in the next few weeks, as you're discovering how to make interactive artworks in P5, when you create an interaction, you're designing affordances. And I would call the things you make interfaces. They're ways of interacting with a computer. You could imagine how you're communicating affordances to a participant. Affordances could be obvious, they could be hidden. We're not sure which one they are. They might need to be one or the other. And the question is, how does the participant know what to do? And that's something you need to decide for yourself in your work. I hope that you choose to do something better than to put little signs and arrows in your P5 sketch. Sometimes I see, like, click here in a major project for this class, which is not very satisfying, is it? If you just have to press A, little labels all over your artwork to describe it. If something needs to happen, maybe it should be something we can either discover or something which is obvious. So let's look at how to communicate affordances badly. I'm almost done with the slides. This is the worst volume control in the world. So this was a Reddit thing. People were competing to make the worst UI, the worst interface in the world. Here's a volume control. That's terrible, isn't it? Every single number of the volume percentage has a different radio box. Here's one. The percentage value of your battery is the same as the volume. So you have to charge your device up. And when it's charged, fully charged, maximum volume. This one's a little, I've forgotten what this sport is called. Someone remind me in the chat. So a little game you have to play to get to a certain volume, which is pretty annoying. Here's one. It looks like it's a bar, right? But actually it's a drawing area, and the more pixels that are black, the more higher your volume percentage. I don't know how you erase them. The intersection of two circles changes your volume. When they're fully intersected, you have 100% volume. Another little game. Whoop. You have to fire the volume dot onto the bar. These are all terrible, aren't they? Another game, you have to keep clicking that button to raise the volume. And this one, you have to move your laptop to a different location to set the volume. That would be an expensive way to set volume. Please make a noise as loud as you want the volume to be. This one seems confusing. And then you realize you have to make the shape of the number that you want the volume to be, 65, and then it will do some computer vision to find that it should be 65. This is when you tilt it. The little game. This is like a golf game, I suppose. Roll the dice and hold different values. So why are these funny? I find them terrifically funny. Curling, I think that's the name of the sport. They're funny because there's an obvious affordance, which is, or one that we're trained to know how to use, the sort of slider with a dot in it. But the actual effect of changing the volume is controlled by a hidden affordance. So that's why they're funny. And the hidden affordance here is usually really weird. Especially this last one where you had the sideways affordance. It looks like a normal volume scroller, but it's actually sideways, right? It's super weird. It just breaks your expectation about it, and it's funny. Don't do things like this, but it's good to imagine what a bad interaction is. So before we do some coding, I want to talk about a few interactive art myths. Myth 1, all digital art is interactive. Myth 1, well, nope. Digital art doesn't have to be interactive because it doesn't have to react to a participant. Here's an example of an artwork which is super cool. Digital, uses digital projection and computer graphics, but it's just a movie or something displayed on a screen, images on a screen. It doesn't have any sensors to react to participants. Another myth, all art is interactive art. After all, there are always people viewing it, and they could view it in a different way. Well, you know, good point. Good point. People do view in art, and their perspective is important in it. But normal art doesn't require the participant to engage in some specific interactions for the art to work. People can stand there and look at it for 2 seconds. They might stand there and look at it for hours or days or weeks and keep considering their artwork. Like this beautiful image, Thomas Struth at the Art Institute of Chicago. I've been there, I've stood in front of that artwork like this person here, that could be me, and just thought, wow, this is just, it's a really incredible painting. But I'm not interacting with it. I'm not engaged in a feedback loop. I'm processing it and engaging inside my brain with it. I'm not engaging in the outside world. Myth. Games are interactive art. And this is, again, one that's a bit controversial in this class sometimes. I'll take a sip of water to explain it. No Peru. Games tend to focus on a few things, moving through a story or developing a skill are common things that games focus on, not enhancing engagement through interaction. Back to the coughs. And this doesn't mean I don't like games. You folks know I love games. Games are amazing. But games are a specific art form. They're a specific thing. They're not the same as interactive art. It's just a different type of art form, really. Some games can be seen as interactive art, and some interactive artworks have game-like elements, but they're not the same thing. And the games which are really interactive art, the games that are interactive art, tend to be games that aren't very gamey, like Katamari Damacy. It doesn't really have a story. You just sort of do stuff in the world and have a good time, have a rewarding experience. Journey, another game which is really seen as arty. It lasts like 60 minutes, right? It's a short game, and I don't know if you folks have played Journey. It might be a bit old now, but it's an experience which relies on your interaction with the world and your experience meeting other players online and having no way to talk with them. and no idea about what the goal of the world is except moving forward on a journey. It's a very simple and beautifully drawn, beautifully artistic game, but doesn't really have any gameplay. You're just existing in a world and moving through it. There's no story really. It was a very vague story, very, very light. There's no really skills. It's easy. It just exists in it. Yeah, I know. Katamari Damacy has a story, but it's a weird, boring story. And the story is not the point of Katamari Damacy, really. The point is rolling up stuff and having a good time. Slander. Look, I'm not gonna. It's not a games course. It's an interactive arts course. There's a lot of overlap between these things, but I just want to express the point that they're not the same. And I want to express the point really clearly that, I know there's a grumpy person in my chat, I want to express the point really clearly that making a weak game as a response to my requirement of you making artworks is not really answering the question. So be careful about making gamey things. Sure, use game-like elements, but having scores or winning and losing in your interactive artworks is usually not a good idea. Interactive art overall tends to be much simpler and more explorative. And I would point you again to the examples of interactive art I have in this lecture about what I'm imagining when I imagine an interactive artwork. Yeah, class policy, don't make a game. Take game dev if you want to do that. Everyone should take this course. Game development. Starts next year, so if you haven't heard of it, good reason. It's also really hard to make a game in P5. Not a good idea. You should use a game engine if you want to make a game, because the game engine is designed to help you do that. P5 is designed to make artworks that are much simpler. Yeah, summary. So, interactive art involves the audience. Interactions have to be designed. Affordances are the action possibilities of your artwork. Affordances relate to hardware or software. Affordances lead to engagement. And don't make a game. That's the summary. I've got these interactive artworks again. I won't talk about them now. I'm going to do some work in objects in P5 with my fireflies. Where are my fireflies? We're going to have objective fireflies. So here's where the fireflies ended up last week. I think there was a few, that cool idea, don't need that right now. Here's where we were up to. And they're really cool, but they're not interactive and they don't have objects. So I'm going to change those two things today. So first of all, I'm going to get rid of this stuff. And we're going to have just one big array. And now instead of pushing onto 3 arrays, I'm going to make an object and push it onto 1 array. So I'm going to say let f equal an object. So far so good. F has got an x location, random width. It's got a y location, random height. And it's got a b, the brightness, random 1000. There's my firefly. This is easy. And I'm going to add it to my list, or my array, sorry. Fireflies dot push f. So now I've created an array of objects, and it only took a few seconds really. And this is much neater, isn't it, than having 3 arrays, one for each property of the fireflies. And now I can actually change a few things about my sketch. I'm going to change this to draw, be called draw firefly. And rather than take 3 values, it's going to take a single f for a firefly. So when I see a b, it's going to be f.b. And when I see x, it's f.x. You can see why I like the dot notation. Very similar, very simple. f.x, f.y, f.x, f.y. Yeah, regarding there's a chat about Katamari Damacy, maybe it's a bad example. I mean, tell me like, and then we're saying that visual novels, like the more story-driven games are interactive art. I would disagree with that because I think that they're more like an interactive movie, and movies are definitely not interactive art. We try and think of some games that sort of look more like the experience of the interactive artworks I showed. Ones that don't have narrative, that don't have predefined interactions, that don't have winning and losing. I think those are, or there are aspects of some games that include these interactive art set pieces. Something that you could walk up to in a gallery and just interact with without thinking about it. So here's my draw Firefly, and this is a great conversation to be having. I'm glad we're keeping it respectful. I have had issues in the past with students in this class who've come in and really gotten upset by me saying, please don't make a game. And at some point I needed to clarify that point. I've taught this course a few times. I would say, we suggest you don't make a game, and 50% of students would make a game. I would say, please don't make a game. 30% of students will make a game. And now I'm saying no games allowed, because I just need to be clear about what the expectation is. The expectation is that what I receive when I ask for an interactive artwork is not a game. And I think that it's fair to have a strong communication of expectations in a course when we're requesting an assessment item. Get rid of that. So where am I going to draw these fireflies? I'm actually going to use a different construction for my for loop. I'll use a for of loop. For let f of fireflies. This is a good one. Now I don't even need my iteration number. So everything is very neat here. And what I can do is I'll just comment this out for now. I'm not going to use it. And I'm going to draw my firefly. How simple is this? A 3-line for loop. There's my fireflies. They're not moving right now. We're going to do the moving in a minute. Let's make another function for moving the firefly. Function modify firefly. So this is going to be the regular sort of jitter flying around action that these fireflies do. I could probably do this in a faster way, but I just thought it'd be neat to do it this way. So we've got f the firefly, f.x, and we'll use the plus equals that we learned in the lecture. Plus equals random minus 2, 2. I'm using all of the tricks today to make my code very small, because when your code gets more complicated, it's much easier to read it if you've used some of these little tricks to keep things short. f.b plus plus. We just add 1 to that. So I've got my fireflies. I'm back to where I started with moving fireflies, but look at my draw loop. Oh, so neat. Super neat, isn't it? Just draw and modify, and my one for loop there. This is looking pretty cool. So I did say that I wanted to do some interaction with my fireflies. I wanted to do interaction. So I'm going to make another function I guess I could put this in the modify Firefly. People keep chatting to me. I don't know who it is. 26 locations. Uh-oh. Oh well, deal with that later. Can't deal with it by giving a lecture, can I? Function interact Firefly. You can do whatever you want in functions, right? But I'm just choosing to divide actions into three little groups. So it's kind of clear what's going on. So when I do my interaction, I really want to deal with mouse X and mouse Y. I'm going to do mouse interactions. So how about if, we're going to find distance. I'll do a bit of maths. Does anyone remember how to find the distance between two things? Like, this is very much a year 9 maths problem. You got two things in XY space. And this one's got the location A, B. That one's got the location C, D. How do you find the distance between them? Do you remember? Make a triangle. You get the distance for this leg. That's going to be D minus B. And the distance for this line in the triangle is C minus A. There's a question, which is, do objects usually go in setup? They can go anywhere you like. It's up to you. I just put them in setup because I wanted those objects. I wanted the list of fireflies to be set up before I start drawing. So if you need something to be set up, you put it in setup. If you don't need it to be set up, you can make them in draw. You could make them every single time. But if I put the fireflies into draw, it would be making new ones every frame, which is not what I want. I want one specific list of objects, specific list of fireflies, all created at once. So we can use, remember the old Pythagoras? We want the length of this leg of the triangle. So we need to do C minus A squared plus D minus B squared, and then the square root of all that. Bleh. What a pain. I'm going to have to check my JavaScript because I don't know if you can do numbers. Operators. Operators? Expressions and operators. Oh, I can use, I need to do a squared, and I forget which languages you're allowed to do 2 times signs to mean an exponent. So if I have something in JavaScript that I want to square, I can say C minus A times 2. So that is the same as C minus A squared. Just a bit of computing. Some languages don't have that, and it's annoying. Where was I? Oh yeah, I need to find the distance between the mouse and the firefly. Distance, or let distance equal square root mouse x minus f dot x times 2 plus mouse y People got it. I'll get back into this game art discussion because there were some really cool things happening, suggestions. What was I going to do? Oh yeah, I'm going to say if the mouse is close, if distance is less than 10, if distance is less than 10, I'm going to do something to this Firefly. I'm actually going to modify it a bit more. So if I get close to the fireflies, they'll start to move more. Is it working? Oh, I haven't used my function yet, have I? Whoops. Put it in there, F. I don't really know why it's doing that. Oh, distance minus 10, distance less than 10. Whoops. Okay, when I move closer to them, they should start to jitter around a lot. I have to get really close for them to do that. I'll turn up the distance a bit, distance less than 50. So I've already got a bit of interaction. That wasn't too hard, was it? It's not great interaction, but it's something. What if we try something a little bit more interesting, where I'm going to move close to them, and they're going to move away from the mouse. So I'm going to add the distance between the mouse and f of x, f dot x. We'll turn that down a little bit, 0.1 times mouse x minus fx, f dot x, and do the same for y. Oh, they're moving towards it. They start to follow my mouse around. And I could probably collect them all up. This is only happening if they're nearby. If I took this out of the nearby bit, everyone comes close to the mouse. Let's try that. They all go close to the mouse. I don't want that. I only want ones nearby to notice my mouse and go close. So we put this inside this if distance is less than 50 bit. Sometimes this is a bit, it's cool gathering together, but we might want them to actually run away. So let's, instead of doing that, we'll minus the same thing. So they run away from my mouse a bit. So the first example where they were chasing the mouse, they tend to get bunched together. This way they tend to spread out, which is kind of nice too. Because if they all bunch together, you kind of lose the effect of having them at different places around the screen. So I'm imagining kind of an assignment submission based on this. Maybe it's like a Firefly, a spell casting station where there's fireflies, and maybe there's some other objects around, potions or energy or mushrooms or something, or plants or leaves. And as you move around, your mouse kind of moves these fireflies, but it might work in different ways when you're in different parts of the screen. Maybe the fireflies have a different kind of behavior as well. They might also want to just all go towards the center of the screen. So in modify or in interact, I could have some other behavior, f.x plus equals 0.1 times width divided by 2 minus f.x. So moving towards the center of the screen in an x dimension, moving towards the center of the screen in the y dimension. And maybe I'll have them doing this really slowly. I'll change that to a y. You know, my mouse has got to spread them out. Oh no, I just got this little circle. And we could just start to experiment with different ways of interacting with the mouse this way. That's kind of cool, isn't it? They sort of cascade out when I mouse over them. I'll put this one inside there. Or maybe I'll have another if distance less than 100. I don't know what I'm doing here. I'm just experimenting to see if it's interesting. So some of the ones near my mouse, they run away from my mouse, but they also run towards the center of the screen. So I kind of herd them up into the center. And I guess this is, so far, this is some nice interaction. It hasn't quite got to this artistic level because there's not a feedback loop going on. There's a bit of a feedback loop where I'm playing with the little fireflies and seeing them move. Actually, I'd like to change their, I had thought about how to draw them that would look a bit cooler. Size plus random minus 2. Random 2, I suppose. And they sort of squiggle, look a little bit more alive. So I can see, I've got this kind of interactive scene going on. You can see the fireflies moving around the screen, but there's not a lot more to discover after this. I'd like to have another layer or something. So maybe over time, or the number of ones I touch or something, something changes so that the experience is enhanced. I get to another level of interaction over time. Once I've interacted enough with my fireflies, something cool happens. But I've shown you some basic interaction techniques with the mouse. Interaction techniques with the keyboard can be good, but they're usually not as exciting as ones with the mouse, because the mouse, in a computer, the mouse is our way of exploring an interface. We tend not to walk up to a computer and say, oh, I wonder how it happens if I press D, right? Nothing, usually. We only type keys when it's obvious on the screen that we need to, and we get some kind of text prompt or a document to type in. So if you want interaction in your work, usually mouse interactions are a better place to start than key interactions. Whoop. Well, we'll do some evolution of the interaction. How about we work out whether all of the fireflies are close? Uh-oh, my Teams just exploded for some reason. I wonder how we can do that. Work out if all the fireflies are close together. Function test closeness. We'll test how close they are to the center. How about that? Test centeredness. F. So we'll do distance to the center. Width divided by 2 minus fx. Height divided by 2. And let's see if the distance, if distance is less than 100, I need to put that in regular parentheses. Then let centered equal false. Else centered, oh, false. So here's the trick here. I'm going to run this test centeredness. There's going to be a variable up there. I'm going to run test centeredness on every F, on every Firefly in my draw loop. And then if any single one of them is outside my radius of 100, near the center, when we get to the end of the loop, that value will still be false. If they're all centered, the value should be true. And if they're all centered, we'll do something. I'll just print something out for now. Print, whoops. And I'll make them all float to the middle a bit faster. Get them all centered up, round them up. Oh, they're all centered. It starts. I need them a bit closer, I think. Fireflies are centered. So I'm going to stop that print value. I actually put the if centered up here. It doesn't matter where I put it. I'm going to change the background. Because it's a global variable, the value of centered will be still there the next time I run the draw loop. So I can put it at the top as well as the bottom, and it ends up the same. But I want to do my background to change. So I'm going to change the color of the background based on centeredness from green to red. So there could be something in your sketch like this, which changes under a certain condition. Oh, what? Oh, background. I was going to have a big reveal of it working at the end. I think I'm going to wrap it up after this. We've got some really nice object-oriented, object version Fireflies, and we've got some interactions, which are pretty cool, I think. And then it changes color. So maybe something else happens once they change color. The Fireflies... Oh, the Fireflies should change color. That'd be much better, wouldn't it? The Fireflies change to Firefly halo color equal color. What's the color down here? That was the Firefly's halo. I'll just make it an array. I'll make it an object. R, G, B. I could use the color object, but I just don't know how to use it, so I'll use my own. So if they are centered, if they're not centered, oh, that's the Firefly itself. That's the halo color. 10, 10. Whoops. 10, 10. So I'm just going to make something so that the halo color changes when they get to this point. They get angry or active or something. They go more red. More actually purple. No, what's red and green? make that just halo color. It's a bit too wordy. All right, we'll see if it works this time. Ooh, well, that was cool. I might need to fine-tune the interaction here so it's not so blinky. It's a bit annoying, but pretty cool nonetheless. Okay, folks, I'm going to call that a day. I'm going to post this in the chat in a minute, today's work. Thank you so much for joining me. Next week, we talk about sound and music computing, your introduction to using sound in P5. Please have a go at assignment 2. Fork the assignment. I'll be hassling people starting the start of next week if you haven't forked it and started, so get ready for that. Have a great rest of the day, folks, and I will join you on Monday. As always, you can put a few comments in the chat, but I'd love to see lots of forum questions and forum ideas if you've got more ideas, particularly on this idea about what makes interactive art interactive art. I'd love to hear your ideas. Thanks, folks, and I'll catch you next time.